Everyone. I'm Victor, client engineering at Airbnb, and gonna continue our theme of AI here and projects that we're all working on with AI. I'm going to talk about how I approached, with the help of AI, converting a GUI-based environment into a GitOps environment. Before I begin, I have to say that the views and opinions expressed in this talk are my own and not reflective of the views of Airbnb or its affiliates. Any content provided here is informational purposes only and is not intended to represent official Airbnb statements, policies, or positions. So yeah, let's get started. Uh, everyone is familiar with Chrome. A lot of people are familiar with Chrome management for enterprise fleets. Um, and most Chrome management is done in a GUI in the admin console. And I want to show what I've done to create a GitOps code first approach for that management. But first, we're all kind of familiar with issues with admin consoles and GUIs. There's no version control. There's limited ways to see context behind changes. Why we set certain policies certain ways. There's often no peer review mechanisms or clean ways to revert changes. And then specifically with the Google admin console, it's very hard to get a holistic view of the fleet and what settings and configurations are set on those. You're left clicking through groups and OUs and trying to reconstruct what is actually getting enforced across the fleet. So Terraform provides a good option for turning configuration into declarative version controlled code. We have all the PR benefits, the peer reviews, Git rollbacks, and all that. But when it comes to Google Workspace, there's been like a lack of an up-to-date workspace provider. There's several forks out there. If you go to the Terraform repository, there's all kinds of different versions in different states of implementation and support. The official Google Workspace provider has been archived for several years. So there's lots of new features that have been missing from that. So I set out to create a system that addressed some issues that were lacking and update sort of an approach to managing Chrome policies. I wanted something that was not only more capable than the admin UI, but also a lot easier and flexible to use for any team. I wanted to expand available capabilities that the providers just didn't have. Newer API controls and features like group-based policy assignments, and creating like dynamic groups and support for easily organizing your priority overlaps. So if you are familiar at all with group management, with policies, you have to kind of define what order those policies land in if users are in multiple groups. But also, GitOps can be daunting. Some people lean towards the UI because it is easier to click the buttons. So I wanted to make a GitOps system that was also easier to understand. YAML files tend to be easier text-based files than repetitive Terraform resource calls and having to know the intricacies of Terraform. So I wanted to focus on a simpler schema language that also gave us the expansive ability of Chrome policies. So at the end of the day, a Chrome or a Terraform provider is mostly CRUD operations. So I tasked that to the AI. I had it learn the Google documentation that exists. I gave it a non-production environment to test things in. And pretty quickly, I was able to create all of the backing functions that a Terraform provider needs to match those missing APIs. And that left me time to focus on sort of the rest of what I was interested in, which is in designing an approachable system in a code-based platform. So I started designing how I wanted to interface with it every day. Again, like I said, I wanted it to be simple text files. And this here too is where AI came in really handy. It handled all of the conversions. So I basically went back and forth, just kind of sketching out how I wanted, my text files to look, and it figured out how to convert, that platform, those blocks into actual Terraform resources that matched the provider that I had just worked on. And so what I came to is this Chrome management platform. It is 6 Terraform modules that work tightly with each other. The main components here being policies. That's what I was trying to solve with this. We can assign Chrome policies to groups, OUs, in the same manner, and very easily assign all of the values and parameters that come with different policies. Extension handling is also a sort of somewhat complicated aspect of Google Admin. It's a whole separate UI for it, but under the hood, it's essentially the same APIs. So what I did with this Terraform module was kind of split out at the top level its own keys that are more specific to extensions. So we can very quickly set an extension to a group or OU, and then at the very top level there, we've got like install types and configurations that are really easy to set. And then I also wanted to be able to create those groups very easily. So what I added to the providers that have been missing is the ability to create dynamic groups. So we can create groups out of other groups, out of OUs, out of user parameters like email or name, or other custom parameters like location or departments. And the other, like I mentioned, the other confusing aspect of it was the how you define the priority. If anyone here manages Google groups with policy assignments, the UI for ordering those can be very confusing. It's unclear when settings will be merged together or override one another. So I wanted to be able to easily create a default policy ordering. So I've got all these groups, I can assign policies to them, and then I can assign the ordering, and I don't have to think about it every time. If my group is in an ordering, it'll just, I can look at that order and know exactly where a user lies and what policies they'll land in. And then if we do need to deviate from the default, the Terraform provider or module supports creating individual policy orderings per group, or sorry, orderings per policy. And then there's some other quality of life GitOps features like reusable variables, so we can define lists of users, of host names, and we can reuse those across multiple policies, so across different extensions or policy values. And the nice thing is that we can update that value in one spot instead of clicking around our OU tree or our different groups and finding those different lists to update. And the other nice thing is that the YAMLs are backed by a schema validation, so we can plug that into our CI/CD processes, and we can have error checking before we deploy any policies out to Google. So when we put it all together, it can look something like this, where this is an example of a single YAML file. On the left here, we have a couple wallpapers declared. We assign those wallpapers to policies that are assigned to groups. And then we have a group ordering. So I can very easily tell orderings apply from top to bottom. So I can tell if a user is in which group, which type of wallpaper policy they will land in. On the right, there's an example of 2 variables for groups and for allowed hosts. And we create a dynamic group again, the group uses email and an OU, so it will join all of the users in those. And then we assign an extension to that group, and we use our variable there to set the allowed hosts for that extension. And then, like I said, we can easily go in one day and update our allowed host variable, push out that change, and all of our extensions that are set with that allowed host name list will be updated. And the cherry on top is that the modules reference our YAML files from anywhere that we give it a path to look for. So we can really organize our configurations however way we want. So we can have that full everything in one giant file, like I showed in the previous example. We can have a file per module here, like this middle one, or we can be really flexible and we can organize our policies via department or whatever way makes sense to us. And the Terraform modules will kind of gather all those up and create our policy for the Google admin. But you know what else is really good at reading Markdown file? It's AI. So regardless of however way we write our YAML files, to make sense for us humans, AI is also really good at consuming that. I've fed the structure of what I like to structure the configs in to an agents file, and you can just ask it all kinds of questions about what's deployed, what your configuration is, and it reliably answers it back because it knows where you've put things. So some quick takeaways about using AI on this project. I try to always learn from it instead of just kind of blindly trusting what it spits out. So I like to ask it a lot of times, like, why are we doing it this way, or why did this come out this way? I've also found that asking it why a lot of times will make the AI self-review itself, and it's like, well, yeah, that doesn't make sense, and then it goes and rewrites a piece of code. I also like, this has been mentioned earlier today as well, but kind of making the AI interrogate you back, make it question your decisions. A lot of times I'll write a command out and my brain's already like 10 steps ahead, and I won't very clearly spell out what I actually wanted. So having it kind of ask me questions back fills in a lot of those edge cases that I sometimes didn't even think of. And then using AI to find gaps. The Google API and documentation is not perfect. There are lots of bugs in there. I found myself going back and forth with what I expected an API to return, what the AI expected an API to return, and what Google was actually giving us back. In these cases, I would have so many iterations of trying things out that I had enough to build a support case out of it. And so I found myself just using the same AI agent to build a case for me to just copy and paste into a support channel. And I found that doing that, I got much better responses from first tier responders from Google, and a lot of that like boilerplate troubleshooting was cut out of it. Like I could see the responders understanding the issue and then getting back to me with, okay, we've engaged engineering, or we've opened a bug for this. It cuts out a lot of that step of going back and forth. And then just some more AI kind of tips and tricks here. When working on these sort of separate Terraform modules, I found that it would often kind of lose track of what went where, and it would kind of start like rewriting parts or kind of overlapping parts. I found it really helpful to have it update its own documentation, have it write the documentation as it's spitting things out. So that when those context windows refresh and everything, it's still understanding of what you wanted out of this, out of all of your commands. And hallucinated APIs, like I mentioned, a lot of the APIs for Google don't make sense, or are more complicated than maybe they should be. And the AI would often assume certain calls worked a certain way. Um, what I had to do here was I created a script to have it pull down all of the Chrome policy schemas and how the APIs, all the values for the APIs, and I had it use that to check against itself when writing configurations. And as an extension of that, that then becomes a CI job in itself. And so now when we push, we are also checking against that that schema of that Google has in their end. And so yeah, in summary, with the help of AI, I cut down a lot of that repetitive um, sort of CRUD operation building and got to focus on just sort of a design for a GitOps system. At the end of the day, it's just simple code, but it can work for any team. We can have security teams just very quickly scan this and ask questions off of that configuration for what's set to what types of groups. And then it's also really easy to go in and manage our own files with YAML code. So I'm working towards getting this open sourced. I would love to have the Terraform and these modules in the Mac admins community so that it's not splintered like it's been for so long, and it would be nice to build and expand this beyond just Chrome management. And I would love any feedback.